Hi, Mr. Minnick here, helping you do your homework, collision detection worksheet number 1. So imagine that this is the top part of a Visual Basic form here. We know that the default width is approximately 300. I didn't draw it to scale too well. The 100 and 200 are kind of wider than the 200 to 300, but oh well. So we have this line that we drew with a draw line command in form paint. And the line obviously goes from the point 150 to the point 250. Maybe you want to write those labels in. That would make this worksheet easier to do. Oh, I messed up. I put the y first. I should have made this 100, 50. And this point over here would be the 200, 50 point. Okay, well, here's the exercise. Complete the if statement so it detects a collision between a picture box named PIC-X and the horizontal line in diagram A. So let's imagine a picture box right here, a little square or rectangle, and its name is PIC-X. So we need something like less than 20 or greater than 30. Something like that needs to fill in this blank. Well, let's see if you can help me figure out what needs to be in there. As this picture box named PIC-X is traveling in the north direction and collides, bam, with this horizontal line, what edge of this picture box is going to cross over that line and touch it first? Oh, the top edge. This top edge is going to hit that line in like 1 or 2 microseconds as it travels in that direction. So the top edge at the moment of impact, or actually just after the impact. So let's erase it from that position and let's pretend that it just impacted that line. And it just crossed over it the teeniest amount. At that precise moment, the top edge is less than 50 on the y-axis. It comes out here, if you drew a little dotted line, dot, 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 dot over here, it comes out to like 48. So anything less than 50 indicates that it collided coming from the south and traveling north. So that is how you would fill in the first blank on this worksheet. If PIC-X.top less than 50. At the same time that its bottom is greater than 50. Because at that moment of impact, the bottom edge here, see the bottom edge that I'm emphasizing, is greater than 50 over here on the y-axis. It might be at the spot like 55. And this was a 48 if you didn't remember what I said. So at the moment that the top edge is 48 and the bottom edge is something like 55 or 56, at that moment you know it's collided. Well, not really, because what if it was over here? See, over here at this hallway portion of the maze that we're drawing on this example. See, right here the top edge is less than 50 and the bottom edge is greater than 50. But it hasn't collided with this line. So having these two parts so far in our if statement is not enough. We have to continue with our logic and say if all that and PIC-X.right is something. Well, let's erase what we have so far and analyze that. If the right edge of this picture box is coming in from the left, that is, if the guy collides from that direction, like a balloon touching up against a needle, bam, or pop actually. At the moment of impact, I ask you, what do we know about the right edge of the picture box, this right edge of it? Well, we know that the right edge is dot, 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 dot. It comes out to about here on the x-axis. At about the spot 103, I'm going to predict. So as long as the right edge is greater than 100, which was the left x endpoint of this line, anything greater than 100 will indicate a collision took place. Well, we've now analyzed the possibility of the guy hitting from the bottom, and we actually, whether you realize it or not, analyzed the possibility of him hitting from the top, because his bottom edge became greater than 50. We now have to analyze the fourth possibility. The picture box being over here, and the picture box slamming into this maze wall from the right. Now, which edge would hit first? The left edge. Correct, Bailey. The left edge would hit that end point first. And at the moment of impact, or more precisely, just after the impact, what could we say mathematically about this left edge? Would anybody in my 2013-14 period 7-8 class like to offer an answer? You'll be recorded in this video for at least 10-15 years. So I asked some student in this SMART class in 2014 what mathematical fact would be true about the left edge of this fictitious picture box the moment just after it collided with the endpoint here. Elvis!
It would be less than 200.
Less than 200 is correct. The left edge, I fill in here, would be less than 200 at that moment of impact. So there you have it. Those are the four inequality expressions that you need to fill in with this if, and statement that would determine whether or not a picture box has collided in any way, shape, or form from any direction with this line segment, the horizontal line segment that we drew in this first diagram. Now let's work on diagram B, a vertical line. So I need more people to speak up here and fill in answers. Give me a second here to reposition the... Okay, so let's imagine a picture box here coming in from this direction. And what mathematical fact could I stipulate about the right edge of that picture box and this line segment that happens to be at these points, 30, 130, and 100 on the X and Y axes? Volunteer? What about the right edge? Greater than, less than, and tell me what number. In other words, tell me what to fill in the blank here in this if statement. Nathan?
Greater than 130.
Wrong. Sorry. It's greater than something, but not 130. The right edge, 130 on the x-axis is way over here. And this right edge has nothing to do with this spot way over here. Try again, Nathan.
So greater than 100.
Yes, greater than 100. You used this y number in a situation where it was not relevant. Hey, I'll give you another chance, Nathan. If the picture box is coming from this direction and its left edge crosses this line, oh, right here, what should I use to fill in this blank for pick x.left? Nathan? At the moment, just after the moment of impact, what is true about this left edge here that's not true about it over here?
It's less than 100.
Yes, very good. It's less than 100. So let's now erase all this what-if scenario, and let's imagine that the picture box is up here, the player in this maze is up here, and the bottom edge of the picture box collides with the end of this line segment. Hey Nina, what would be true about this bottom edge just after impact with the top of that line? Very good. And you don't even go to this school, and you knew the answer. This was your first day of class. Somebody else from the room. What would I say about the top edge of this picture box as it collides coming from the bottom, so we can finish all four sides of this vertical line and fill in this last fill in the blank? Dan?
Less than 130.
Very good, less than 130. Because at the moment, just after impact right here, the top edge would surely be some number over here on the y-axis that's slightly less than 130, like 128. So it's okay in this assignment that you're doing, Maze 2, it's okay if the person does see themselves go through the line for like a microsecond. But then a second later, a message box will pop up, or you'll call the reset method that resets them back to the beginning of the maze. So that's just, yeah, it's a little cheesy, but it'll look good. Don't use equal symbols. Don't use pick x.top equals 50. Because of the glitchiness of Visual Basic and the way that our program works, the left edge or the right edge in some cases will not exactly match the line that it's colliding with. It'll like hop over it slightly. So you can't use an equal symbol even though that logically makes sense. You need to use a less than or greater than symbol. If you want to use less than or equal to's, that's fine. For all of these inequalities, if you wanted to add the equal symbol right after the inequalities like I'm doing here, that would have been fine. Actually, that arguably would make this a better style program. Any questions from my period 7-8 class here? Okay, hopefully you guys can now scroll down this worksheet and fill in the whole if statements in numbers 4 and 5 that match the 2 additional lines that I am explaining there on the worksheet. You're going to have to draw a little piece of graph paper on your own and draw these 2 lines in here on your graph paper and then write out the whole if statement. I prefer that you go in this same order, top, bottom, right, and left if it's a horizontal line, and then right, left, bottom, and top if it's a vertical line. Even though it would work any way you want to write those parts, it'll just be easier for me to grade. Have a good day.